Welcome back to ACER Explained. In this video series, I'm going through Section 3 of the ACER Practice Test booklet. In this video, I'm going through questions 66 to 69, and so that's Unit 21. I'm going to be identifying prerequisite knowledge, reasoning skills used, as well as the bootcamp resources that can help with this. So in this unit, we're given a chunk of text that describes platelet activity, and we're also given two figures. We're given two graphs there as well. So what we're going to do first, I'm just going to summarize some of this information to be able to answer question 66. So I'm just going to start off by summarizing most of it. So starting off with paragraph 1, the important information that I'm seeing here is that they circulate for 10 days in humans, and then they're cleared up by the reticular endothelial system. And then in the second paragraph, we have some information about some proteins. So we have BCLX, and it says that it enhances platelet survival. So I'm going to put that there. And then you have ABT 737, and this inhibits BCLX, okay? And then you have BAC, which decreases platelet survival because it says it triggers death. So it triggers platelet death, okay? And then you have another substance there. So we have BCLX, which is the one that we talked about earlier. It's known to inhibit this substance here, which makes sense because if you're decreasing platelet apoptosis, you're going to increase platelet survival, okay? Then we have some more information in the third paragraph. And so it says that caspase 3 is what ABT 737 actually activates. Okay? So looking at caspase 3, where did it come up? It actually came up in the paragraph before. And it says that the way that BAC actually induces the apoptosis is by impacting this apoptosis simulator, which is caspase 3. Okay, so what this does is it simulates caspase 3, which leads to apoptosis. Okay, and so we're also told that the presence of ABT 737 increases the activation of caspase 3. So it upregulates this little bit here and results in increased apoptosis, which makes sense because BCLX is the opposite of apoptosis. It's increasing platelet survival. And so if we are told that ABT 737 actually acts in the opposite way, well, it says that the effect is countered by ABT 737, then this is just the mechanism by which it's counted. Okay? Now, it does also say that when BAC is actually not present, then ABT 737 doesn't have any impact. So BAC must be present. I'm going to write that down here. All right. So now we have question 66, okay? So this is basically a bit of a summary of that, all of that information, all of those paragraphs into a little kind of diagram or flowchart. And this can be really handy to just be able to summarize a unit, and then you can use this to answer multiple questions from that unit. So now let's look at question 66. Which of the following is the most readily achievable and useful to prolong platelet lifespan in blood banks? All right, so we want to prolong platelet lifespan. So we also want, that means that you want to decrease apoptosis. Okay, so let's look at our answer options. A, decrease the rate of transcription of BAC mRNA in mature platelets. So what does BAC do? Remember, BAC acts via caspase 3 and increases apoptosis, right? So by decreasing the rate of BAC mRNA in mature platelets, could this potentially increase lifespan? Okay, it could. Then we have option B, increase the rate of transcription of BCL-X mRNA in mature platelets. And so this we know is used to increase platelet survival. And so by increasing the rate of this transcription, so when you say increasing the rate of transcription, you're just saying that you're increasing the amount of a particular thing that's a particular protein in a cell. Because by increasing the transcription, you're increasing the translation of the protein, and therefore you're increasing the amount that's in the cell. So sure, this could also be a potential mechanism. Then you have C, which is administer ABT737. Now we know that ABT737 actually enhances caspase 3 activity and results in increased apoptosis. And so this is incorrect. Well, we know that this cannot be correct. And then we have administer QVD. So we're also told in the 4th paragraph that QVD inhibits caspase 3 activity. I'm just going to get rid of this. So QVD inhibits caspase 3 activity, and this is a drug, just like ABT737. So this could also work. Now we have the most readily achievable and useful. Okay, so looking at the rates of transcription, right? Decreasing and increasing the rate of transcription of a particular protein is very difficult. It requires modification at the gene level, okay? And so these options are actually not very readily achievable in blood banks, right? This is not something that's achievable. However, this is just a drug that can be administered. You can just give this drug to a patient. And so this is quite readily achievable. So D is the correct option here. And that's how you had to kind of differentiate between these 3 options, which seemed all kind of correct in terms of prolonging platelet lifespan, but these 2 didn't address the other aspect of the question, which was the most readily achievable and useful aspect. So for this question, you didn't need too much prerequisite knowledge as well. You needed some knowledge about genetics in order to rule out those first 2 options. So just understanding what it would actually mean to alter transcription. And the reasoning skills used here were interpreting chunks of text. So the way that we kind of made a little diagram for ourselves, that is really useful. And the process of elimination. So the bootcamp resources that can help with this are the reasoning skills course, the acceleration class, chunky text, and the content in action on genetics 1 and 2 if you just want to brush up on genetics. So question 67 is asking us a more general question. So you don't actually need any of the information that's provided there to answer this question. It's asking us about half-life. So it's saying to reduce the percentage of platelets produced on a day to just less than 5%. So just less than 5%, that's key. By day 10 after production, the half-life of the surviving platelets must be close to what? So first of all, what does half-life actually refer to? Half-life refers to the time that's taken for your whatever it is. Usually it's isotopes, but in this case we have platelets. So how long does it take for 50% of your platelets to be gone, essentially, right? And so we start off with 100% of our platelets, and then after one half-life, you go down to 50. So that's what a half-life is. And then after a second half-life, you would go down to 25%. After a third, you'd go down to 12.5%, and after a fourth, around 6.25%, and then 3. Let's just say 3.1 for now, percent. So this is 1, 2, 3, 4, 5 half-lives. And you're being asked about when, essentially, do you get just less than 5% of the original platelets. And so that is what you get at half-life number 5. Okay? So half-life number 5, you get just less than 3.1. Up here, it's still just above 5. 3.1 is just below 5%. So the key here is to look at half-life number 5. And so this here, we are told, occurs over 10 days. It's basically asking, if this occurs over 10 days, then how long is one half-life, right? So if these 5 cycles are happening over 10 days, then how much is happening over one cycle? And the way you figure that out is just 10 days over 5 cycles is equal to 2 days per cycle of halving, right? And that's the definition of a half-life. So you have each half-life being 2 days. So the answer is B. For this question, it was helpful to know what a half-life is to be able to know how to approach this question. And the reasoning skills used here were just pattern recognition. So being able to figure out what the question is asking and then also kind of find that pattern within the half-life to be able to calculate that final question answer. And then identifying the irrelevant information. So all of basically recognizing that you don't actually need all of that information to answer this question. And the bootcamp resources that can help are the reasoning skills course, the acceleration class on pattern recognition, and there's a content in action on nuclear physics that introduces this idea of half-lives as well, if you want to familiarize yourself with that. So question 68 is asking us about figure 1b. It's asking us to compare the effect of half-life of BACs, and these other two, BCLX and BAK. So we haven't come across BACs yet. So looking at the paragraph above our figures, we're told that BACs has a similar effect to BAC, and it actually promotes apoptosis. So I'm going to add that in here. Okay, so that's the role of BACs. Then we're given this figure, and I want to explain what these mean. So plus, 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 minus, and minus, minus. So in this experiment, what happens is that you either keep it normal, which is plus, plus. So the gene activity here is normal. Both of your genes copies are functioning. So this is normal activity. Then you have plus minus. So plus minus is a partial knockout where you're partially reducing the activity of that gene and therefore you're partially reducing the activity of this particular protein. And so that means that the effect of the protein is going to be reduced. Then minus minus is a complete knockout. So you're completely knocking out this gene, which means that the activity of the protein is completely gone. Okay? So that's what this means. And so now looking at our answer options, where we're asked, does BACs have more of an effect on platelet half-life than BCLX? Does it have more of an effect on platelet half-life than BAK? Does it have any observable effect on half-life? Or does it have less half-life, or less effect on the half-life than these two? So first, let's start off by looking at whether it has any effect at all. So the way that you would do this is, first of all, you would compare this reduced activity to one of these normal activities, right? Because you want to see what happens if you get rid of BACs. And that will tell you how much of an effect it's having on half-life. Because if you get rid of it, then something is going to change. If nothing changes when you get rid of it, then That means that there's no effect on half-life. But which one of these do you actually want to compare this to? Well, what you need to do is make sure that these other two values or these other two scenarios are constant. Because, for example, let's say that you compared this with this, right? Sure, you would get the effect of what would happen if you knocked out a little bit of backs, but you would also get what would happen if you knocked out all of back. So then you can't actually tell whether the difference that you're seeing here between these two, you can't really tell whether that's because of backs or whether that's because of back. So what you really want here is for your other two variables to be constant. And in this scenario, we have that. So we have this is constant across these two columns, and this is also constant between these two columns. The only thing that is changing here is the BAX being reduced. So we can see here that reducing BAX has this effect on half-life. And if you look at your copy, it's a lot easier to see how it corresponds to the values. It's around 0.5 days of half-life difference, okay? So we can see that there is an observable effect, so we can eliminate this option. Now let's compare it to BCLX, okay? So I'm going to erase this here to make it a bit less confusing, and I'll just leave that bit. So looking at BCLX, now we want to see what's the effect of BCLX, so then I can compare it to the size of the effect of backs, right? So looking at BCLX, we have these two that are knocked down a little bit, and these three are normal. Now, which ones can we compare? So over here, we have negative, 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 positive, positive, and positive, positive. But then we also have here positive, positive. This is constant across the two, and this is constant across the two as well. Now, let's look at both, all right? So let's just compare both. Now, when you're comparing these two, you'll find that the difference in half-life is approximately 0.9. Okay, so close to 1, all right? And then when you're comparing the other two, so when you're comparing this column to this column, you'll find that the difference looks to be around, honestly, less than 0.5, so even 0.4, let's say. But which one of these do we actually use, right? Well, we don't actually even have to pick which one to choose, because based on figure 1b, this is figure 1b, you can't confidently say that BAX has more effect on platelet half-life than BCLX. So you can eliminate this option for now. Obviously, we have to get back to this here, and so when we get back to it here, I'll explain that. But for now, we can't say that BAX has more effect on platelet half-life than BCLX, right? Because here, you can see that it has a greater effect on half-life. And you can't you can't just look at this one and say that this one has a greater effect, right? So now I'm going to erase this, okay? And now we're going to compare all of this to BAK. So looking at BAK, we want to figure out where, we have our constant option. So looking at BAK here, we have negative, 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 positive, positive, negative, negative, and positive, positive. So we want to compare these two because this is constant, this is constant, this is constant, this is constant. So then the only thing that's really changing here is the negative versus positive effect. And so the effect that you're seeing here is, I want to say, around the same as BCLX, so around 0.9 as well. And so you can't say that BAX has more effect on platelet half-life than BAC. Confidently, you can't say that. This is not the most strongly supported statement. So that leaves us with D. And D is telling us that BAX has less effect on platelet half-life than both BCLX and BAK. So if you're looking at 0.5 compared to the 0.9s, then yes, BAX does have less effect on platelet half-life than BCLX and BAK. But then we have this 0.4 here. We kind of have to figure out what's going on there. Well, when we looked at 0.4, the difference, we also had a difference in BAK levels, right? And we're told in our stimulus that BCLX acts via BAK. So if BAK is not there, so remember up here, acts via BAK. So if BAK is not present, you can't actually see the full effect of BCLX. And so that's why you would disregard this one and you would look at the other two options there. And so this is the most supported. Now, you might have noticed that for these, we were looking at the plus minus versus plus plus for these two. And then for BAC, we only had minus minus. And so I agree. That's a bit of a tentative conclusion that I would come to there, because you're comparing a complete knockout with partial knockouts. However, the question is asking which is most strongly supported. And so I would still confidently be able to say that the answer to this question is D. So the previous knowledge that would have been a little bit helpful was a little bit of knowledge on genetics and how those knockouts work. So the plus plus, minus minus, and plus minus. But you can also kind of use your pattern recognition skills to kind of infer what that would even mean, right? So what would plus plus mean versus what would minus minus mean, and what would plus minus mean, right? So you can kind of infer that using pattern recognition skills. And you also needed to be able to identify the relevant information here, interpret graphs, and use the process of elimination. So the bootcamp resources that can help with this are the reasoning skills course, the acceleration classes on diagrams and visual stimuli and graphs, and on pattern recognition as well. Then we also have the content in actions on genetics if you want to brush up on some genetics. Okay, so let's go through question 69. So we're being asked which is the most consistent with the information provided in terms of explaining the lifespan of a platelet. So let's go through the process of elimination. So we have A, the number of BAC molecules in a platelet increases over time. So BAC, we see up here, is responsible for decreased platelet survival and increased apoptosis. So I'm just going to write that there. Then we can move on to the next one. The effect of BAC on caspase 3 decreases over time. So remember, BAC acts via caspase 3 in order to increase apoptosis. So BAC upregulates caspase 3, which increases apoptosis, right? So overall, this would decrease apoptosis, right? Because if you have less of that effect of caspase 3 activation, then you have less apoptosis. Then we have option C. The levels of unbound BAC increases over time. And so what it means by unbound BAC is that essentially you have more of the active form of BAC. Okay? So when any protein is bound, that means that it's not able to function as per usual. Once it's unbound, that's when you will get kind of initiation or activation of BAC. And so this would result in increased apoptosis. And then we have caspase 3 activity decreases over time, and that would decrease apoptosis. So as the lifespan progresses, we know that platelets die. That's something that we can get from the stimulus, is that they circulate for around 10 days and then they are cleared out, right? So that means that the options that say apoptosis is decreased would be incorrect, right? Because if apoptosis decreases over the lifespan, that means that they'll be kind of immortal. Okay? So now we have to compare options A and C, and which is the most consistent with the information presented. This is very important. So we have A is that apoptosis increases because the number of BAC molecules increases, or the levels of unbound BAC increases. Now, although it's helpful to have that kind of prerequisite knowledge of, if a protein is bound, it's not going to be effective, and if it's unbound, it's going to be effective, you don't actually need that, because in the stimulus, we are told that BCLX is known to bind BAC, right? And so BCLX, through binding BAC, inhibits apoptosis, right? And it does say that the way that apoptosis actually occurs is that BCLX levels decrease over the lifespan. And as BCLX levels decrease, this inhibition decreases, right? So as BCLX decreases, your BAK levels increase. Well, your unbound BAK level increases, your activity of BAK increases, and that's how you get apoptosis. And so that's why C is the most consistent with the information provided. If you didn't have that information provided, then A and C are quite valid explanations if you were just told this bit of information. But you want to look at the whole picture here. You didn't actually need any prerequisite knowledge for this question. The key here was being able to simplify into a visual way, or any way that makes sense to you, that chunk of text, right? You just need to be able to simplify that and interpret that, and then use the process of elimination. So the bootcamp resources that can help with this are the reasoning skills course and the acceleration class on chunky texts. And that brings us to the end of this unit. Please like, share, and subscribe for more GAMSAT help. We really value your feedback. We have our Instagram at Thank Flip GAMSAT, podcast at Thank Flip GAMSAT, nurses doing GAMSAT if you want to hear more from us. And I'll see you in the next one.